Division of complex numbers. Two subtract j5 divided by 3 plus j4. To divide these, we have to multiply by what's known as the complex conjugate. We look for the complex conjugate of the denominator. So if the denominator is 3 plus j4, its conjugate is 3 subtract j4. The conjugate always has the opposite sign for the j term. If it was plus here, the conjugate is a negative. Or if you had a negative to begin with, the conjugate would be a positive, so it's always the opposite sign. So we multiply the numerator and the denominator by the conjugate of the denominator. 3 subtract j4, top and bottom. I'm going to write this in brackets. Now we'll begin by multiplying the denominator. 3 threes is 9. Outers is negative j, 3 times 4 is 12. The inners is j, 12, and the lasts is negative j squared, 16. Following on from this, we can see that the j12 and negative j12 cancel out, so the j terms are gone. In this part, j squared is equal to negative 1. So when we subtract negative 1, this means the final term is actually add 16. So the denominator becomes 9 add 16. And this denominator is always real. That's why it's handy to use this complex conjugate of the denominator, because we end up with a real denominator. And carry on the next page. 2 subtract j5 multiplied by 3 subtract j4, and that all ends up being over 9 plus 16. So there is a shortcut to get the denominator. We just look at the conjugate, which had the 3 and the 4, and 9 was actually 3 squared, and 16 was actually 4 squared. This is always the case for the denominator. The numerator we have to work out in the normal way with brackets using FOIL. 2 threes is 6. The outers is subtract j8. The inners subtract j15. And the last is plus j squared 20. This is all divided by 25. Here we replace j squared with negative 1. So the numerator simplifies to 6 subtract j8, subtract j15, subtract 20, all over 25. 6 subtract 20 is negative 14. Negative 8 subtract 15 is negative j23, all over 25. Or we can write this as negative 14 over 25, subtract j, 23 over 25. 4 plus j7 to subtract j3. To divide these, look at the denominator and multiply it by its conjugate. 2 plus j3, the opposite sign but the same numbers. Multiply the numerator by this as well, otherwise we're changing the complex number. So we're multiplying the top and bottom by the same thing, therefore we haven't changed it, it's an equivalent fraction. The numerator, 4 2's is 8, outers is j12, inners is j14, and the last's j squared 21. The denominator will take the shortcut, 2 2's is 4, 3 3's is 9. It's always going to be 2, the first number squared, and 3 is the second number, square that, add them up. The numerator is 8 plus j12 plus j14. Subtract 21 as we replace j squared with negative 1. Denominator is 13. Now 8 subtract 21 is negative 9. 13. Sorry, negative 13. And 12 plus 14 is 26. All divided by 13, so we'll divide them individually by 13. And that ends up being negative 1 plus j2.